All right, this video is going to go over 13.2, 13.3c. It's just more practice on this exponential growth and decay. So let's look at some of these word problems. Remember, you're using this equation y equals a times b to the x, where x is your time, b is the rate, and then really it's like 1 plus or minus your rate, your decimal, and then a is your starting amount. And y is going to be your final amount. So just keep that in mind as we do this. So like this first one, they say there's a new truck worth 29,000. Well, there's your starting amount right there, 29,000. And they say it depreciates. It means it goes down. So 12% each year. So you got to go get this rate. So you do 1 minus, because it's going down, it's depreciating. And then 12% is 0.12. So you get this rate as 0.88. That's your B value. And then what's the value of the truck after 7 years? That's your time. So that's to the power of 7. So all you got to do is punch this in the calculator. So let's see, 29,000 times 0.88 to the power of 7. I get 11,000, and it's dollars, so 11,851.59. Nothing to it. All right, this next one, a bank account has a balance of this. Well, that's your starting amount. So y equals 160.10. Oh, wait, hold on. They're going to want to know the initial amount invested. So they're looking for the start. So this balance of 160.10, that's actually your finish, 160.10. It's your Y value. You don't know your starting amount. That's what you're looking for. And they say it's grown at a rate of 4% every year. So your rate here is 1 plus 4%, which is 0.04. You have to divide that by 100, remember? So 1.04 is this B value. And then time is 12 years. So to solve this, go get a value for this 1.04 to the 12. 1.04 to the power of 12 is 1.6. So 160.10 equals 1.6 A, or times A. So to finish solving this, you just divide by 1.6. And if you get a different number than me, it's because I'm not rounding on my calculator. I'm pulling the whole value. It's actually 1.601. So that might be why. But anyways, if you punch this in, 160.1 divided by that, you get 99.997. So we'll just call it 100. So it was a $100 start. Okay, next one. We're back to depreciating. It means going down. And it says at a rate of 8.5% every year. So you do 1 minus 8.5 divided by 100 is 0.085. So you get, I think that's 0.915. That's your B value. So, and they're going to want the original value of the machine. So we don't know our start value. We know our finished value, 24,000, so that's Y. So it's just like the one above it, 24,000 equals, we don't know the start, times the rate is 0.915, and then look for time. So they say after 9 years, like this. All right, so all you gotta do is get a value for this 0.915 to the 9. 0.915 to the power of 9 is 0.45. And so to finish solving this, just divide by 0.45. You should get like 53,385.26. And again, if you get a slightly different number, it's because I'm not using 0.45. I'm actually using 0.44956. So. All right, and this was dollars, so dollars. All right, the next one, there's cell phone users growing 22% each year. So I would go get my rate right there. So we're growing, so it's 1 plus 22% is 0.22. So your rate, your B value is 1.22. All right. Now, they say from 1995 to 2003. All right. So 34 million is your start. 34 million. Yeah, that's your A value. So you go Y equals 34. We'll just put 34 right now, and then we're dealing in terms of a million. So 34 times that rate, 1.22 to the value of time. Well, from 95 to 2003. So 95, you got 96, 97, 98, 99, 2000, 01, 02, 03. So that's 9 years, right? Be careful not to just subtract those and assume it's 8 years. Whenever you're in doubt, just write it out over here. It's 9 years. So that's your time. Now you got to just punch this in the calculator. 34 times 1.22 to the power of 9 is 203. 203.57. But remember, we're in terms of a million. So, and they want us to round to the nearest million. So we'll just call it 203 million. So that's how many at, after 9 years there. Oh, and by the way, if they're asking for write a function that models the usage, like look at this first one, write a function that models the value of the truck. You just, instead of time, you just put an X. So like it'd look like y equals 29,000 times 0.88 to the X. So don't overthink that. All right. So like this one would have been y equals 34. Remember, in terms of millions though, times 1.22 to the X. All right. So don't overthink that. All right, look at number 5. We're back to depreciation, okay? And so let's see what we have here. I'm gonna go ahead and write the equation, AB to the X. All right, they give me the decay factor right here. So they're giving me the whole B value already. I don't have to do like 1 plus 1 minus. They gave me the B value. And then they give you the time and they give you the final price, and they want to know the original value. So just plug everything in. Your final price is your Y. So that's 90. Okay. That's 98. We're having technical difficulties here. Just 1 second. All right, let's try this again. 98,304 is your Y value. You don't know your start. You know your B value is 0.8, and then it says 5 years. So give 0.8 to the power of 5 a value. It's 0.33-ish. And then just divide by that 0.33. You're probably going to get a different answer here because mine is actually 0.32768. So 98304 divided by that is 300,000 on the dot. So your starting amount was 300,000. So that's how you do those word problems. Now, we're also going to have to do some graphing. So remember, exponential growth looks like this. Exponential decay looks like this. Then you just got to watch out for like reflections. All right, so this is a reflection across the x-axis of my red here. So it's actually going to look like this, with the asymptote being right here. Now I go get that asymptote. It's at y equals 2. I shouldn't use green. It's not going to show up very well. Okay, there's the asymptote. And now go get your y-intercept by plugging in 0 for x. So it's like negative 4 to the 0 plus 2. So that's negative 1 plus 2, which is 1. and then just make it take this shape. So it looks something like this. Your domain's all reals because it goes left forever, right forever. And your range, the lowest it goes is negative infinity. The highest it goes is the asymptote of 2, and it does not hit it. All right, this next one, it's just a normal exponential growth function. So it looks like red. And I'm going to go ahead and get my asymptote, which is at this -1. There's your asymptote right there. And so you know it's going to take the shape of red. Now you just got to go get the y-intercept. So that's like 2 times 3 to the 0 minus 4 is -4 minus 1. So that's 2 times 3 to the -4 is 1/81. So you get 2/81 minus 1, which I'm going to get the common denominator. So it's -79/81. It's almost at -1. It's really close. And now it just takes the shape of the exponential function. So it would look something like this. Your domain's all reals. Your range, the lowest it goes is that -1. The highest it goes is infinity. If you didn't understand this 1/81 part or this part, you need to work on your fractions some. Okay, the next one. This is exponential decay. So it's going to look like the blue function to the right. And so that's the shape it's going to take, is like the blue, like this, with your asymptote being here. Your asymptote is at y equals -4. That's here. And now you just got to go get that y-intercept. So if you plug in 0, you get 1/3 to the 3 minus 4. Well, that's 1/27 minus 4. So that's 1/27 minus 108/27, which is -107/27. That's basically almost -4. It's really close. So it's like here, and then just make it take the shape. So I'd say it looks something like this. It's not great, but that's okay. I care more about general shape and y-intercept. So the domain's all reals, and the range, the lowest it goes is that -4, and the highest it goes is positive infinity, like that. All right, and then this last one's just exponential growth, so it's going to look like red up there. You do not have a shift here, so that means y equals 0 is your asymptote. And so now I would just be like, okay, well, what's the y-intercept? You would plug in 0 for x, so you get 2 to the -5, which is 1/32. So it's really close to 0, and then it just takes the shape of an exponential function, just like that. So your domain's all reals. Range, the lowest it goes is 0, but it doesn't hit it. The highest it goes is positive infinity, like that. Okay, and then in terms of if these are growth or decay, you want to look at the b value, the one with the exponent, right? So like this, and like this. So this is growth because your 4/3 is bigger than 1, right? So the next one's decay because it's less than 1. Now this next one is growth, and it looks like this until this negative would reflect it across the x-axis and make it look like this. So I'm guessing that they're wanting this one to be decay. I'm not really sure what they want on this one. We'll call it decay. It's kind of a weird question. All right, and then the last one, 2/3 is less than 1, so this is decay. You know, actually on this third one, I'm not going to call it decay. I'm going to call it growth with a reflection. But again, I'm not real sure on that one. So I more so care that you can do these word problems and that you can kind of graph and know the general shape of the graph and be able to get the y-intercept and the asymptote, etc. So hope this video helped.